In this section, we're going to take a look at the normal versus the standard normal density curve, just so that we can get an idea of what happens to a distribution when we try to normalize it. So in the first graph, we have a normal distribution where the mean is 1. And so what you'll see is it moved over to 1. And the standard deviation is 4. And so with a standard deviation of 4, and from the empirical rule and Chebyshev's theorem, we assume that 95% of the curve is going to fall within 2 standard deviations. So 1, 2, 3, 4, that would be 1 standard deviation. 1, 2, 3, 4, that would be 2 standard deviations. And if I go in the other direction, starting at 1, 1, 2, 3, 4, and 1, 2, 3, 4 would be 2 standard deviations in the other direction. So what we want to know is we want to convert this to where it's going to fall on the normal curve. So we have the normal density with a mean of 1, standard deviation of 4, and the shaded region presents the area that's greater than -7. In order to convert anything onto this normal density curve, we're going to go with one of my favorite formulas. They're calling it normal, so we can do z, although we could also do t. And our formula is always observation minus mean divided by standard deviation. Now, when we get to bigger samples, we're going to divide that by the sample size, but we don't have a sample size. We just have 1 observation. So our sample size is 1. What we're observing in this normal curve is the -7. The mean of the distribution is 1, and the standard deviation is 4. So we're going to get -7 minus 1 over 4, which is going to give us -8 over 4, which gives us a value of -2. So if I were to convert this onto the standard normal curve, I would start at a value of -2. And since that is shading to the right, I will also shade to the right. So let's take a look at that one more time. In this case, they're giving us a mean of 1, a standard deviation of 2, and we're looking at the area between 3 and 4. So we want to come up with one z-score that's going to transition this onto the standard normal at a location that would be 3, which is above the mean, and a second location that's going to transition this to a 4, which is above the mean. So we're going to start with the idea that we know the mean is 1. We know the standard deviation equals 2. And the first observation that we're going to focus on is the value of 3. And so if we go to do the z-score for 3, our z is our observed minus the mean over the standard deviation. And at some point, that will be divided by the square root of the sample size. But again, our sample size here is 1, so we're good. So we're going to do 3 minus 1 over standard deviation of 2. So that gives us 2 over 2. So this location is going to convert to the value of 1 on the line. Now we're going to go back and do the same thing for the value of 4. We're going to try and figure out where 4 is going to fall onto this line. So now our new observation is going to be at 4. So we would take 4 minus 1 over 2, which is 3 over 2, or 1.5. So this is going to convert to a line at 1.5, directly between 1 and 2. And then we just want the area between, so we're going to color the area between. So the formula that we're going to use consistently is what we observed happening, which is what's happening on the graph, minus the mean, which is mu, divided by the standard deviation.